Hello, everybody. Welcome to Olga channel. All right, so please, my name is Cindy, and then I'll be continuing with another topic today. All right, so before I step into the field, I want you guys to subscribe to the channel if you haven't, like the video after watching, and also share to a friend. I also want to tell you that God really loves you, no matter what you are going through. No matter how difficult studies can be sometimes, remember that God loves you, that He is ever ready to help you sail through your endeavors. God bless you. All right, so I'll share my screen. Today I'll be talking about sample distribution. All right, so sample distribution is similar to the standard normal distribution. So with the standard normal distribution, it's talking about an entire population, but the sample is just a part of that population. You get it? So it's just the same analogy, but then since this is a part, it will have some kind of adjustment to what the formula for the entire population. So when it comes to look at sample distribution, and if time permits, we'll just look at some questions and the probability that we can solve together. All right. So I'll share my screen. Then we'll head straight right into business. All right. Hello. All right. So share my screen. But then let's look at this question. So I'll use the question, then as you go through the question, what explain what the sample distribution what means. All right, so as I said earlier, sample distribution is just looking at the probability of what sample mean. You see, so with the entire population, for example, when we have something like the ages of what level 200 students. That's about an entire population. But then we come back and we say that from in that level 200 student, we just pick think or UGBS 301 students. So that's UGBS 301 students is a sample of that entire population. All right. So when we talk about sampling distribution, not something difficult, but then we want to look at some formulas. Okay, so we know that in our normal distribution, our standard normal distribution, which pertains to the entire population, sometimes our or the figures or the values you are looking for cannot be attained using the normal probability formulas, but then we have to use the standard normal distribution table. So before we can even use that table, we have to look for the z value. So this concept applies towards the sample distribution, just that some adjustments will be made to the z value, since now the sampling is not about the entire population, but just a part of the population. All right. So someone will say, so with the sample distribution, it's what about means. Okay. So let's say I pick UGBS 301, or which is a part of level 300 as one sample, and then I'll look for thing 301 student, which also was part of what the level 300 student, that's the entire population. So when we look at the mean of the thing 301 and then the mean of UGBS 301, that's and we do what we use the normal distribution table for. That's what sample distribution is all about, right? So now instead of looking for only students in level 300 who maybe have incomes above 300, now we are looking for students in what thing 301 who are part of what the entire level 300 students who have what more than 300 cities on them. You get it? So that's what the sample distribution is about. All right. So with the sample distribution, when you want to use the z um the z table, that's the normal distribution table, the formula goes like d is equal to the sample mean. All right. So we know that in the normal distribution table, it was z is equal to what the value. All right. So that was x alone. But now we're looking at what a sample mean. So we know there's this assumption that, or there's this fact that the sum of all what sample means is equal to the population mean. All right. So the z value in the sample distribution is what? Sample mean minus the population mean, all divided by, so you divide all by what? The standard error. So now in sample mean, we are not looking at standard deviation, but we are looking at what? Standard error. So in the normal or in the entire population's aspect, we are looking at what? The mean and then the standard deviation. But in sampling distribution, we are looking at what? The sample mean and what? The standard error. Do we get it? And we know that sample mean emanates from what? The population mean. That is why here it is what? Sample mean minus what? Population mean divided by our standard error. When we talk about standard error, what are we talking about? So standard error is just, so let me label it as SE. Sorry, SE. It's just the standard deviation from what? The population, right? So standard deviation from the population divided by what? The square root of um the number in the number of the sample size. Okay, so the square root of the sample size. So that is the standard error. So maybe in a question you might not find standard deviation when we ask find the standard error. So the standard error is just the standard deviation from the population divided by the square root of the sample size. You get it? So in mathematical terms, this sample mean is written as x bar, right? And then the population mean is written as what? Mean, right? And then the standard error is from this formula, right? So standard deviation, which is of this symbol, something like that, divided by what? The square root of the sample size, right? So this is basically the how to find the z value. So in the population, or when there was no sample, when you're doing the normal or the normal standard division or the normal distribution, we saw that it wasn't x bar, it was what? X. So let's say if you are using the entire population instead of a sample, we can say that how many, looking for students who scored more than 45. Do you get it? So that will be your X. But here it's a sample mean. So it's like we got from we took a particular sub. So instead of looking at the entire level 300 students, we took only UGBS 301 because we can't go back to every level 300 students and ask them for their marks. So I say we took 301 students alone. You know, using that as a basis to judge, or we use that as a basis for the entire population. So since I can't go from door to door to ask for people's marks, what if I take 301 students, because they are accounting students, they're BA students. So maybe if I pick that sample and I use them, I'll be able to predict what the entire population would be. So that's the idea of what the sampling. Do we get it? So that's why it was a sample mean. That's not, we don't just pick 45. So you can't say that we want students who got more greater than 45 in the entire population, but we can't go by one. So we'll pick the UGBS, right? UGBS class, the entire class for only UGBS. Then we get number of students who got 45. Then we'll find a mean for that, and we'll compare with the entire population mean. So just to know, oh, okay, so looking at only this sample and the entire population, this is what my conclusion would be. So standard error is just maybe okay, how should I put it? How correct or how wrong you can be by your words, your assumption. So something like that. So let's bump straight into the question and then we'll understand it better. You get it? Please don't exit the video. Like and subscribe. God bless you. All right, so the question here says a population has a mean of 120 and a standard deviation of what? 25. Suppose a simple random sample size is selected and used to estimate what? Estimate mean. So this one was mean, but I couldn't write it or type it. So I wrote U into bracket mean. So it's used to estimate what mean. What is the probability that the sample mean will be at least 128? Do you get it? What is the probability that the sample mean will be at least 128? All right. So first, before you start jumping into anything, just to know what do I need, what item do I need, what am I looking for. So in mathematics, you have to just write them down first. It don't give you the idea of what type of formula you should use. But if you just look at, oh, it's talking about standard deviation, just pick the Z for the normal standard distribution. You're going to get it wrong because this one is about sample distribution, not the entire population distribution. All right. So first, we know that they said the entire population mean is 120. Entire population mean is represented by what? Mean. And we are saying that is what? 120. All right. If the entire population is mu is 120, they are saying the standard deviation for that population is what? 25. Is 25. Now they are telling you that suppose a simple random size is selected, right? So now they are going to pick a particular aspect of the population. All right. So they're saying suppose a sample size is selected and used to estimate the mean. All right. So the sample size is 45, sorry. So let me write it here. Sample size of 45. So the sample size 45 will mean that n is equal to 45. And they are saying that find the probability, or what's the probability that the sample mean is at least 128. So we know that our sample mean is what? 128. So now that you'll be able to fish out the needed information, you know that this is what a sample distribution, because we have what a sample mean here. So you just plug it into this formula, which is what the Z, because we have to use the table to find for what this figure. We can't just use the normal probability formulas. Use the table. All right. So our Z will be equal to our sample mean, which is what? 128. Minus our population mean, which is what? 120. Divided by our standard error. Standard error is what? The population standard deviation, which is what? 25. Divided by the square root of the sample size, which is what? 45. The sample size you are looking for, which is what? 45. So now I'll use our calculators. Then we'll find what the Z value will be. But take note, for sample distribution, before you can confidently use the Z value, you know that the standard normal distribution is for what? The entire population. But now we are using sampling. So before you can confidently use the Z, you have to make sure that this sample size is what? Greater than 30. Else, you can't use the what? The Z distribution. So the sample size must be what? Greater than 30, which is what? Large enough to represent an entire population. You get it? So if it is greater than 30, it is considered large enough to what? Represent an entire population. So that's the condition to use the Z table, or the Z table, however you call it. So that will compute for our Z value here, which is for the standard, the sample distribution. So 128 minus 120 divided by 25 on root of 45. So I got 2 points. I hope today no calculation errors. 2.15. So this is a point. 2.15. All right. So these are Z value for the sample distribution. So this doesn't end here. I'm not going to read. But before you read, you need to draw to know where the question demands you to go. Which direction should you move? To the left, to the right, center, middle, between, or not? All right, so we first have to draw. Since we know that the sample size is greater than 30, means we can use the normal distribution curve to represent. But now, instead, we are looking at sample means. All right, so we draw our curve. Today it looks better. Then we know that the middle will be our mean. And then one thing we should know is that the mean of what sample mean is equal to the population mean. What does it mean? So let's say I pick in a population let's say with 50 students in a class, and I ask for their ages. Everybody gives me the age, and I pick 20 out of that 50. I'm using that for my analysis. And then I find the mean for that 20 to use that for my analysis. Then I pick the maybe 10 out of that 50, and I find the sample mean for my analysis. If I add all those means, I have to get back the mean for the entire population. That is this assumption. So I'm not sure, but let's try it out and see if it will work here. So let's say I have the entire population, figures like 12, 13, 14, then I have, say, 15. So we are trying it out to see how true this assumption is. I haven't tried it out, it just popped up in my mind. So let's see. So let's say I pick the entire population. So this is the entire distribution for the population. So in that population, we have, let's say, 4 members. So if you want to find them, you know that is the addition, the sum of these distributions over the number of what members, right? So we have 12 plus 13 plus 14 plus 15 divided by 4, right? So I got 13.5. 13.5 for the what population mean. So now let me take a sample of that population. Let me take only 12 and 13, right? So we are looking for the mean for this sample, which is 12 plus 30 divided by 2. So 12 plus 13 divided by 2. I got 12.5. 12.5. So let me pick 14 and 15 as another sample. So 14 plus 15 divided by 2, I got what? 14.5. So these two, this and this, they are what sample means of a population. And the assumption is saying that if we add the sample mean, right, of a particular population, should give you the what? The population mean. So let's try it out. So now this plus this divided by 2. So 14.5 plus 12.5 divided by 2. I got 13.5. So it means that theorem is what? Valid. So the mean, what actual mean of sample mean is the population mean, right? Because the reason why I did this, because we know that from a normal standard distribution, this middle is what? Mean, right? That's the mean. But then we are dealing with sample distribution. So what would be the mean of sample distribution? What would be the mean of the sample mean? And from this illustration, we know that the mean of what sample means is what? The population mean. So here we can write the mean of what sample mean, which is the same as the population mean. You get it? So that is the mean here that we've gotten. So now all the figures will be what sample means instead of raw figures, raw numbers, but now they are what sample means. So their question is saying that probability that sample mean will be at least 128. So we know that our what sample mean, or the mean of the sample means, is what the population mean. Population mean here is 120. So let's say we have 120 here. Sorry, the 2 is dancing, but it's all right. And then 128 will be somewhere here, right? So let's say we have our 128 here. And the question is saying that probability that it will be at least, so at least means greater than or equal to 120. So let's say this is the 128. So we are looking for this side, right? So this side, right? Okay, so we are using the Z. Since we can't use normal formulas, we are using the Z table. And then we know that the mean is always 0 in the Z table. So here is 0. So this, for the Z for this 128 is the 2.15. And since we are looking for this side, the reading, you have to be careful, right? So this is positive though, but you have to know where you are looking for. So we'll go to our distribution table. And we know that we are looking for this side, right? Right? We are looking for this side, right? So we are looking for this side. But then this table is giving us this side. And we know already from my previous videos, from our lectures, sorry, 1 minute. From our previous videos, from our lectures, that the probabilities or the area under this curve, they are symmetric about the mean. So this side is equal to this side, right? So it means that this side is equal to this side. So whatever figure you get for this side, the same as what will be here, right? It's just like you divided something into half. So if here is 0.5, here will be 0.5. If here is 1.5, here will be 1.5. So that's the meaning of symmetric. So the value here will be the same as the value here, right? So it means that since our table or our graph is giving us this side, but then the table has this side, right? And then we know that this side is the same as this side. Then we can read from the negative table, though this figure is what? 2.15. So let's say you were given only the negative table, we weren't given positive table. But then this question, we know that we are looking for this side, but the table is pointing for figures only in this side. But we know that since it's symmetric about the mean, this side is equal to this side. So we can read from the negative table, and you will not subtract from 1 because of the symmetrical nature of the curve. So I hope you understand this point. So read our 2.15. So we go to ignore the negative signs here, but we know that this side is equal to this side. So look for 2.1 and then we move to 0.05, which is here, because here is 0.00, 0.01, 0.1, 0.2, 0.3, 0.4. So here is 0.5, right? So 2.15, which will give us what? 0.01578. 0. So our answer is 0. So let me say it. Probability that the sample mean. So this is the symbol for sample mean. Don't forget, if you write only X, you are referring to a distribution or a figure in the population. But if you write this, it's showing that you are talking about the sample mean. And they are saying probability that is greater than or equal to what? 128 is equal to 0.01578. So now let's use the positive table and see what we will get. So now we are looking for only this side. So we are, because we know this side is equal to this side, and though this side is for the negative table, but the symmetrical nature of the curve means that whatever I get for this in the negative table, the answer for this side, it doesn't matter whether the z was what, 2, was a positive figure. Since it's symmetric, then it's correct. But let's look at using the positive table, what would we arrive at? So we are looking for only this side, but then let's use the positive table. So now this is our positive table. And then we are interested in this side. That's what our question demands, this side. But then this table gives us this entire side. So whatever figure you get here is within this area, not this area. So we know that probability is what? The sum of probability is equal to 1. So if I know one particular area and I want the other side, I'll subtract from 1, right? All right, so we want this side, but not this side. But what answer we get here is giving us this side. So whatever we read from here, we subtract from 1 to get whatever is here. So we are reading 2.15. So suppose we are not giving the negative table, but we're giving the positive table. This is the analogy that you use. So you have to be very careful. It's very simple. Just know which direction. Is it symmetric about the mean? So this side is equal to this side, or so now I'm reading 2.15. So 2.15 is here, right? 2 is here. But then this is not the answer, because the answer we got here is within this circle. But then we're looking for this circle. So you subtract from 1. So 1 minus 0.98422. So we come here. The second way, using the word positive table. So greater than or equal to 128. Using the positive table is equal to 1 minus 0. Let me read again, I've forgotten. 0.98422. 0.98422, which is equal to, so use your calculator and see what you get. 1 minus 0.98422. We got 0.0157.8. So you see that they are both words the same. You got it? So any of them, depending on the table, just know the symmetrical nature of the thing, or whether where you are looking for is not in where is not part of what the table is giving you. Subtract from 1. So this is how sample distribution is. It is just like our normal distribution, but then there are what adjustments to the formulas and how we read them, and the condition that the sample size should be greater than 30. That is it. So this is where I'll bring this sample mean to an end. But then I'll do another video on how to solve some probability questions, all right? Because I don't want this video to be very long. So please, I hope this video really helped you. I pray that a good Lord will help you understand it better. And please don't forget to like the video, share the video, and also click on your notification bell. God bless you so much. I love you so much, and I wish you all the best. See you in another video. Enjoy your day. Bye. Bye.